Okay. Starting at 48?
Yeah, 48 through 54.
This looks familiar. I remember seeing that picture last time. So, what is g of f of 3? Excuse me. Oh, I've had a cold all day. Okay, here's the way to look at this. Hold on a second, make sure I recorded this session. Look at this function only. Tell me what f of 4 would be.
17.
Okay. What would f of x squared be?
25x squared minus 3.
No, the only thing you do is whatever's inside the parentheses, you plug in for x. So that would be 5, and instead of x, I'm going to put x squared minus 3. You with me?
Yep.
That's the strategy. Okay, so whatever we get in the parentheses, we're just going to plug in for x. Now they're saying, well, what is do the inside first. What is f of 3?
Would it be, so 5 multiplied by 3 and then minus 3, which would equal,
Excuse me, that's not 9. It's 12.
yeah.
15 minus 3. So now the problem says, well, what is g of 12? In other words, when they say g of f of 3, we figured that out first. That's 12. So now the problem becomes, what's g of 12? Now you use that function. That's the g function. What's g of 12?
So 110 or 121.
121. In other words, it's 11 squared. Okay. Now, using the same function machines, what's the reverse? What is f of g of 3? Tell me how to do this from the first step.
So you would
Start from the inside, work your way out. What is g of 3 equal to?
So 3 minus 1 is 2, and then 2 squared, which is 4.
So the problem really is, what is f of 4? Now you got to go to that function again.
So then it'd be 17.
That's how you do these. And order does matter. G of f of 3 was not the same as f of g of 3. First find g of 3, which is what we did, then substitute that into f of x. Whoops. I clicked twice. Okay, here we go. All right, multiply the first ones.
So,
hold on one second. My computer is running slow and it doesn't want to do this. Why does it not want to do this? I was having problems earlier today. Yeah. Took a while to get Windows Ink workspace working. So we're doing this one here. Term by term.
So 3x squared, 3x, or 2x squared.
That's a 1. 1 times 2 is 2.
Oh.
And it's 2x cubed. X times
Yes.
x squared is x cubed. That's the first one.
So 2x cubed minus 3x. Plus 2x squared minus 3.
Good. Simplify. So part of the simplification process is putting them in the correct order.
So 2x cubed plus 2x minus 3x minus 3.
Correct. B, term by term.
So x cubed and then plus 3x.
Hold on. When you go term by term, go in a certain pattern. Do not mix it up. Don't randomly just multiply numbers. In other words, you want to do those two first, then you want to finish the x's and do that one, and then you want to do that one.
Oh.
And then do the next one, all three. But go left to right and finish each term before you go to the next one.
So then it's minus 2x
Squared.
2x squared.
X times minus 2x is minus 2x squared.
Plus 3x.
Okay.
So now you do,
Now you do the 1 times all three terms.
yeah. So then plus 1x squared.
And watch what I do here. Instead of keep going to the right, I'm going to write this one under the other x squared term. Keep going.
And then minus 2x.
I'm going to write that under the x term.
And then plus 3.
Now it should be easier to simplify.
So x cubed minus 1x squared plus 1x plus 3.
Perfect. See the advantage of doing that, where you write them under their common terms?
Yeah.
Okay. C, first step.
Because it's squared, do you have to make it 2x plus 3s?
First of all, that 2 is not being squared. That 2 is not under the parentheses. The square is only being applied to the x plus 3. So let's do that first. What's x plus 3 squared equal to?
X plus 3, x plus 3.
Do that multiplication.
x plus 3
Boil it. You gotta do it term by term.
oh, okay. So it'd be x squared, and then plus 6.
Plus 6x.
The 6x, that's
Hold on. You just made the most common mistake made in algebra. You came up with x squared plus 6. Okay? Well, that's not what you come up with if you FOIL it. What do you come up with? Got to
x
go every
squared
term by every term.
plus 3x, plus 3x plus 6.
Plus 9. 3 times,
Oh,
3 times 3 is 9. Okay?
yeah.
So that gives you x squared plus 6x plus 9, but that's just x plus 3 squared. That's only that part of it. Going to multiply that whole thing by 2. So
then
I do the exponentials first before I multiply it by 2. And now you get what?
2x squared plus 12x plus 18.
There you go. And number D, step by step. What's the first step?
So you have to make it, you have to FOIL 2x minus 3 squared.
Do it.
So you got 4x squared minus 6x minus 6x and then plus 9.
Okay. I'm going to write this over here. 4x squared minus 12x plus 9, all in parentheses, multiplied by x plus 1. In other words, we did this part first. That produced a trinomial term, which we then have to multiply by the original binomial. Do that. And this is where FOIL doesn't really help, but FOIL is the same as every term by every term. So that's all you have to do. Just make sure you start from the left, multiply x by every term, go back, multiply 1 by every term.
So 4x cubed minus 12x squared plus 9x. And then if you multiply all of them by 1, it'd be the same, correct?
Yeah. Okay, I can go for that. 4x squared minus 12x plus 9. Combine them.
Wait, why are you doing that now?
Well, because I did this. I did that, put this flat plus that. That gave me that row. And then I did 1 times that, 1 times that, 1 times that. That gave me this row. Well, I got to add them together.
Oh.
That's why I wrote them under one another like that. I wrote the x squared terms together. I wrote the x terms together. Add them together.
So you'd get 4x cubed minus 8x squared Minus 3x plus 9.
Okay. That's simplified in proper order. Everything we need. Yeah, you can. I don't need to blow that up. I don't think, do I? You make those out.
I think so.
Okay. Let's do A. Let's first step.
Wait, last time we did this, you said you didn't have to cross multiply every time.
This is not one of those.
No.
This one we do have to.
Okay.
The only time you don't is if I have something like the following. Let's say I had 2/3 equals x over 6. Now there's only one x in the problem. It's that right there. So if I'm going to solve for x, all I got to do is multiply both sides by 6. And I get x equal 4. Whereas cross multiplying would give me 12 equals 3x, and then I got to do another step, divide everything by 3. So cross multiplying is 2 steps. Multiplying just by the denominator of x is 1 step. So you wouldn't cross multiply here. There's an example, but what you want to look for is x in the numerator all by itself. We're going to see it when we get to C. But not yet. So cross multiply these. What do you get?
12x is equal to 5x minus 10.
Simplify.
Do you add 10?
No, when you have an equation and you get to a point where you have variables on both sides and or numbers on both sides, then the next step is to get all the terms with variables on one side, the numbers on the other. Well, I already got the 10 over here. To put the 10 on the other side, then I'd have to move the 12x over. So let's just do one step and move the 5x over. Now what do you got?
So just minus 5x.
Okay, what's the next line?
7x is equal to negative 10.
Perfect. X equals what?
Divide both sides by 7. And x equals negative 10 over 7.
Yeah, and you can't do that in any fewer steps. All right? And I cross multiplied. That's all I did. Same thing on B. In other words, I got x all over the place. So I could divide both sides by 3 so that I have x all by itself over here, but then I would have x's over on the left side still. When you solve an equation, you got to get rid of you got to get the variable all by itself on one side and nowhere else. So first step here. Get rid of fractions. Always. Get rid of fractions, get rid of exponents, get rid of parentheses. Well, there's no exponents, but there's a fraction. How do I get rid of the x in the bottom?
Multiply by 1.
Multiply by x, not 1.
X.
Okay, what do you get when you multiply both sides by x?
So 4x minus 1 is equal to 3x squared.
Now what?
Do you have to get rid of the x squared?
No. Learn to recognize a quadratic. A standard quadratic has an x squared term, has an x term, and it has a number. Whenever all three of those are there, then you have to solve it as a quadratic, which means putting everything on one side, leaving 0 on the other, and then factoring.
Okay.
What's that give us?
So you add 1 and subtract the 4x.
Okay, I'll leave 0 over the left.
So 0 equals 3x squared minus 4x plus 1.
Okay. Now let's factor that.
So
First step, split the x's up.
so yeah, so x and 3x.
Good. In other words, after you split them up, they got to multiply it back together again to give you that first term. So it can't be x and x. It's got to be x and 3x or 3x and x. Okay. So now,
It'd have to be a plus and minus.
no, you do not produce a plus 1 if your signs are opposite. Opposite signs always produce a negative. What produces positives?
A negative and a negative, or a positive and a positive.
Okay, and look to the middle term to figure out which one.
So it'd be negative.
It's got to be negative.
Negative and negative.
That means it has to be negative, negative. Now, how many factors are there of 1?
1.
That's it. There are no choices. That better be the answer. How can we tell? Let's check the inside. That's minus 3x. Let's check the outside. That's minus x. It's only 2 we really need to check. Add them together. That's our inside. We did it properly. Still haven't solved it, but we got it broken down into 2 things multiplied together equals 0. So what's the answers?
So x equals 1 and negative 1 over 3.
Positive 1 over 3. The reason is I'm setting 3x minus 1 equal to 0, which means 3x equals 1, which means x equals 1/3. Okay? So in this problem, there were 2 solutions, which you kind of expect, because the moment you multiply both sides by x, you see you have a quadratic. And quadratics almost always have 2 solutions. Number C.
Do you multiply it by 5?
Not yet. And the reason is this fraction here has the x in it. So we're better off if we get rid of that 1/3 first. It's really easy to get rid of that 1/3. What do I got to do? In other words, the pattern you use for equations is you get rid of anything that's being added or subtracted, like constants, first. Well, we have a minus 1/3, so let's get rid of that 1/3.
So multiply by 1/3?
No, you don't multiply. That third is being subtracted right now.
Oh.
You always do the opposite. You add.
Yep.
Okay. So it gets rid of it from the left side. What do you get on the right side? What's 137 thirds plus 1/3?
138 thirds?
Now, can that be reduced?
Maybe.
Well, best way to really do it for you is to just try it on your calculator, see if you get a whole number. Best way for anybody to do it.
Okay.
What do you get?
You get 46.
Okay. Now, next step.
Well, but couldn't you, okay, yeah.
Couldn't I cross multiply?
Yeah.
Could have, but notice that now I got numbers that are bordering on the 690 size. I want to keep my number small. Okay, by reducing this first, my biggest number I'm dealing with is 46. I'm not dealing with any 600s. So this is the same equation as this, no difference. It's just easier to solve because they're smaller numbers. So what's the first thing I do to solve it?
So
2 more steps.
you multiply by 5.
So that gives you this.
And then divide by 2.
And that gives you that. There's your answer. This one here. Get rid of denominators. Always remember that. When you're solving equations, get rid of denominators, get rid of parentheses, get rid of anything being squared. I mean, I want to get rid of this x plus 1 that's in a denominator.
Yeah. So, you add x plus.
What is x plus 1 doing right now?
It's dividing, so you multiply.
Okay.
So you get 4x minus 1 is equal to
Just write it
x.
out for the moment. You don't have to do that step in your head. Now multiply.
So x squared plus 1x minus 1x.
Those two middle terms always cancel one another. Whenever you are multiplying a binomial by its conjugate, you don't have those any middle terms. So in this case, you can say the answer is x squared minus 1.
Okay.
On the right side. Still got this over here. Not done.
So now you subtract 4x and add 1.
Giving me what?
So now you get 0 is equal to x squared minus 4x minus 2.
No. If I add 1 to both sides, the 1's disappear.
Oh, so just as is?
Now I have still got to solve it. Still have a quadratic, but I want to factor it this time, just like I wanted to factor it last time, but this factor is a little different. I can't, this is not a standard quadratic. It does not have a constant in it, but it does have an x squared and an x. So I can definitely do a greatest common factor. Do a greatest common factor. What do you get?
So x multiplied by x minus 4.
Now tell me the two answers.
4, x equals 4.
Huh?
And x equals 0.
Correct. Remember what we're doing. We have two things multiplied together. We're going to set each one of them equal to 0 and solve. Well, first one, x equals 0. We don't have to do any solving. Second one, x minus 4 equals 0. That means x equals 4. So there's our two answers. You do have to be a little careful on this one. What if we'd have gotten x equal minus 1 as an answer? Would that have worked? Would that have been a proper answer? I mean, the numbers were different, and we ended up with x minus 1 as an answer. What's the problem with that answer?
Is it? Well, because
It would cause you to do division by 0. In other words, this denominator right here would turn into 0 if x were minus 1, and you cannot divide by 0. So this is an impossible answer. If you were to get it, you would throw it away. First rule of mathematics, you can never, ever, ever divide by 0. It's not even allowed. Okay. Tells you exactly how to find inverses, and those are the only two steps you ever need to remember. You switch x and y, and then you solve for y. Okay? So, A, get me going. First thing I should write.
Are you?
Switch x and y, and then solve for y.
I'm just.
Do it one step at a time. What's first step?
Switching x and y.
Do that.
So x squared equals y plus 3?
Now, when I say switch them, I mean this. I don't mean switch their positions. I mean just switch the variables. In other words, wherever I saw y, I put x. Wherever I saw x, I put y. That's what switching x and y mean. Okay? Now, solve for y.
So subtract 3.
Now solve for y. You solve that. I said y squared equals 4. How would you solve it?
You'd square it?
It's being squared, so you would take the square root of both
Okay.
sides. Same thing down here. So how do you solve for y?
Square root of x minus 3 is equal to y.
Right. Almost. Not totally. The reason it's not totally is that whenever you solve an equation for by taking the square root of both sides, always begin your answer with the words plus or minus. That's the actual answer. Now, there is a problem here. They didn't say find the inverse function. They said find the inverse. This is the inverse. Turns out that's not a function. That's a combination of functions. The plus square root of, the plus square root of x minus 3 is that. The minus square root of x minus 3 is this. Notice I'm not looking at a function. It doesn't pass the vertical line test. So that's definitely the inverse, and that looks like the inverse because what we started out with was a parabola up there. So what we ended up with is a reflection over the line y equal x. In other words, this is this reflected over that line. And it indeed is the inverse, but it's not an inverse function. But it's difficult to tell here what they really are looking for. Their wording is such that, first of all, I don't know why they gave you a function that is not one-to-one. The original function is not a one-to-one function, which means it doesn't have an inverse that's a function. For a function to have an inverse, it's got to be one-to-one. And then it will have an inverse function. This thing has an inverse, but it's not a function. It's what's called a relation. This thing over here is a relation. I'm not 100% sure what they want. Let's have a look at their hint and see if they'll tell us. Yeah, they did put the plus minus in front. Good. They should. This wasn't sure they were going to. Okay. Whoops. To number B. Hold on. Remember?
So
apply the two steps. Hold on a second.
So
just 1 minute. My thing is going nutty here. All right, now I can take a picture of it. All right, first step.
So switch the x and y and get x equals 1/4 y plus 6 cubed.
In parentheses.
Yeah.
All cubed. Okay, now solve for y.
So
you got to get rid of
subtract.
You got to get rid of the cube. You got to get rid of the 6, and you got to get rid of the 1/4. Which order?
Do you get rid of the 1/4 first?
No, because the 1/4 is under the cubed. It's hard to get rid of that. How can I get rid of the?
So we have to get rid of the cube then. So cube root both
squared. We took the square root of both sides. When you're trying to get rid of a cube, what are you going to do?
Cube root it.
Okay. So we got the cube root of x, and you write that like that, equals what?
Is equal to 1/4 y plus 6.
Now you got to get rid of the 6 and the 1/4. Which one gets rid of next?
Subtract 6.
Okay. Equals 1/4 y. Now what?
Multiplied by 4.
Good. And you kind of got to do it in parentheses like this. Well, I guess you don't really have to, but you want to make sure you put the entire left side in parentheses before you multiply by 4. I could write this answer the following. It's y equal 4 cube root of x minus 24. In other words, go ahead and multiply that out, and you get this. That's the inverse. Okay? Now, notice one difference. Over here, when I took the square root of both sides, I started my answer with the words plus or minus. When you take odd roots, you don't do that. If I'm taking the cube root of x, it's the cube root of x. It's not plus or minus the cube root of x. Or if I'm taking the fifth root of x, it's just the fifth root of x. It's only when you're taking even roots, like the square root or the fourth root or the sixth root, that your answer always starts plus or minus. This is correct here. This is probably a little cleaner up there. Same thing. Whoops, got one more to do on this page. Okay, how about C?
So flip the x and the y, and you get x equals square root of 5y minus 6. Then you have to square both sides, and you get x squared is equal to 5y minus 6. Then you add 6 on both sides, and you get x squared plus 6 is equal to 5y. And then you divide by 5 on both sides.
I got to divide both terms by 5. And I can do it like this. That's the same thing as x squared over 5 plus 6 over 5. Don't necessarily have to put it in two terms like that. That is satisfactory answer.
Okay.
Okay? Excuse me. I'm not getting a cold. I'm going to have a hard time finishing this week if I get a bad cold. Okay. When you are going to complete the square, first of all, it's a good idea to have kind of an idea of what we're looking at here. What does this polynomial represent? Any idea? It's a circle.
Oh.
Okay. And the format, the general format for a circle is, hold on. x minus h squared plus y minus a squared equals the radius of the circle squared. So that's what we want to turn this into. If we can make it look like this, h and k are the center of the circle. H is the x-coordinate, the x-center, and k is the y-coordinate for the center. And r is the radius of the circle. So if we know h, k, and r, we can graph it. Now, in order to make it look like this, we've got to turn your x terms into an x minus h squared. And you do that by completing the square. And the first step in completing the square is to get your terms together. I got x squared minus 4x. I'm going to leave some room so that I can complete the square. And then I got plus y squared alone. And I'm going to put the number on the other side. And the reason I'm going to do that is because that's the format that I'm looking at. Notice that I'm getting close to my standard format. Now, how do I complete the square inside the parentheses?
You
Completing the square, you got to memorize how to do this. You're going to have to do it so many times. Take half of the coefficient that's in front of x and square it. It's half of 4.
2
Square it.
8 4.
Okay, and it's always being added. Now I just changed the expression. How can I balance it out? I just added 4 to the left side when I wrote it in there. What do I have to do to the right side?
Yeah.
I got to add 4 also. In other words, now I've got the same thing. I have not changed it. I've just rearranged it. Okay? Now, the reason I completed the square was so I could write that like that. Well, I can now. That is x minus 2 quantity squared plus y squared equals 20. So tell me where the center of my circle is.
Minus 2.
H is positive 2. Remember the format is x minus h. It's always x minus h. It's never x plus h. It's always, no matter what you're dealing with, whether you're dealing with quadratics that you're trying to get in vertex format, or whether you're completing the square on conic sections, it's always x minus h and y minus k. So where's the center of the circle? What's h?
H is 2.
What's k?
2 also.
What's k?
Y squared.
What's k? What k?
Oh, so just y.
Well, that means k is 0. Right? There's nothing with, there's no other y term. So it's this up here, but k is 0, giving you y squared. So I don't have to complete the square for y. It's already in its final format, pretty much. Now, I got everything I need. Hold on. So k is 0. Where's the center of the circle?
At 2 and 0.
Right there. What's the radius of the circle?
20?
That's r squared. Notice
Oh,
that's
so 20.
so square root of 20. So if I draw a
Uh,
circle about that center, I know that this distance is square root of 20. This distance is square root of 20. All radiuses are the same. That's square root of 20. Okay?
okay.
So what's the parent graph and how has it been transformed? Well, I don't like that question, but the parent graph, I suppose, would be a circle at the origin. And it's been transformed by moving it 2 units to the right. But circles are not about transformations of parent graphs. That's why I don't like that part. Let's see what they say. They don't even answer their own question. Unless, oh, hold, yes they do. Hold, no, they don't. In other words, they come up with the same thing we did, but they don't say what the parent graph is and they don't say how it was transformed. That's because this isn't a transformation problem. They shouldn't have asked that even. All right. Laughlin rather. I gotta go. I got a 4 o'clock.
All right.
Talk to you.
Thank you.
You're welcome. Bye bye.